Okay, so our next step is I want to step into equations that look something like this. So here, there's a couple of ways we could approach this. One way is more consistent with what we've done before, but it's a little more difficult. So I'm going to do that way first. This first example I'm going to show you is not the way I would solve this equation. It's just one possible way, and I think it's the most difficult way to do it. But what you can do is, just like, when we had something like this, you could distribute the 5. We can do a similar thing here. When we have a fraction bar and we can't combine what's on the top, we can actually distribute the division. So 3x divided by 4 can be thought of as 3/4 x. 7 divided by 4 is just 7/4, or 1 3/4. And then we can solve this equation using the fractions. We would subtract the 7/4. So we have 3/4 x equals 5 1/4. And then we can divide by 3/4. So x equals 7, right? Bless you. So that's one way of doing it. Now doing it that way, of course, you're forcing yourself to work with fractions. This one could have been solved in a way that avoided some of those fractions. So I'll put them side by side here. We can think of it this way. What's been done here to our variable? X has been multiplied by 3, then 7's been added to it. And that fraction bar says all that on top has to happen first. Then, the last thing that would be done is the whole thing's divided by 4. So to solve this, we could multiply the whole thing by 4. So that's gone. So I've got 3x plus 7 is all that's left here. The 4 is gone. Over here I got 7 times 4 is 28. And now I would solve that by subtracting 7. And dividing by 3. It is. Now you have to be careful because it doesn't always work out that you can do it that way. Let me show you the equivalent of what I mean. Why isn't that you can't always do it that way? We said the same thing when we had a problem like this. Oh, what do I want to make that into? When we had a problem like this, 5 times and 2x minus 3 in the parentheses equals 35. Because I believe somebody even asked, can't we just divide by 5? Well, and in this case we could divide by 5 and make that go away. 35 divided by 5 is 7, and then we could just solve the equation. Add the 3, 2x equals 10, and divide by 2. So x equals 5. But if we had something like this, oh, what do I put in there now? Something like that. Now I cannot divide out the 2. Because if I look at what's been done to the variable here, the parentheses have to happen first. It was multiplied by 3. The 5 was added. Then it was multiplied by 2, but we also had the 2 added on to it. So multiplying by 2 wasn't the last thing done. Here we were able to divide out the 5 because multiplying by the 5 was the last thing done. So I mean, we could go ahead and start taking this apart and disassembling it in that reverse order. It's just, it's much easier to simplify and combine. Like we did, like we've done before. 2 times 3x is 6x. 2 times 5 is 10. Plus 2, combine that to make the 6x plus 12. And then solve that equation. So when we're looking at these fractional equations, so let's say we have 5x minus 2 all over 11 equals 3. This only works because if we were looking at how this equation was built, the last thing that was done building this equation was dividing by the 11. So we can multiply by the 11 to get rid of it. So I multiply by the 11. I'm left with 5x minus 2 on top. 3 times 11 is 33. And then plus 2. 5x equals 35. And then divide by 5. X equals 7. However, if we had something like this, I'll leave that up there for a second for you. Now I couldn't multiply by the 5 first because there's more things there. The last thing that was done in building this equation was not dividing by that 5. Now for this class, I'm not going to force you to solve equations like this. But what you would have to do is you would have to get that fraction by itself. And to do that, you would subtract the 7 first. So 4x plus 3 over 5 is still there. The 7 is gone. 22 minus 7 is 15. Then what do? Divide by 5. Or not divide by 5, multiply by 5. Thank you. Multiply by 5. So you have 4x plus 3. 5 times 5 is 75. And then subtract 3. 4x equals 72. And finally, divide by 4. X equals 18. What do you think? Too much? Yeah. Well, then you might not like this next step. But we're going to do pretty much the same thing, only we're putting in fractions. So what is the first thing that should be done? Now notice there's nothing outside the fraction bar here. So the last thing that was done building this equation is dividing by the 7/8. So when we go to solve this, what is the first thing we have to do? Multiply by 7/8. So on the left side, what we have left is 2/3 x minus 1/4 equals the 4 and the 8 can divide out. Divide by 4 to give me 2 and 1. Perfect. So 1 times 7 is 7, or 5 times 2 is 10. Then what do? Add 1/4. So that's gone. 2/3 x equals 7/10 plus 1/4 is 19/20. And finally, perfect, divide by 2/3. So the 2/3 cancels out there. I have x equals 19/20 divided by 2/3 is 19/20 times 3 over 2. which is 57 over 40, otherwise known as 1 in 17/40. What do you think? Hoping there's not too many of those on the test. I would only put maybe 2 or 3 of those, not too much. Still a lot. Well, let's take a peek now at something, step back a little bit. Look at something like this. So the equation has fractions in it. And one of the ways we've solved it using the fractions. But one thing we could do is we could eliminate the fractions. To eliminate the fractions, I would use a common denominator, a common multiple. So here I only have denominators of 4 and 8. What is my least common denominator for those? The 8. So what I can do is I can actually multiply this whole equation by 8 and make the fractions disappear. Now I do have to make sure I multiply every term, every digit in this equation. So 3/4 x is one digit, so it's 8 times 3/4 x. So I'll make this 8 over 1 times 3/4 x. Now the 8 and the 4 will cross cancel, making this 1 and 2. 2 times 3 is 6x over 1, so that's just 6x. Then I'll do the 8 times the 5/8, so 8 over 1 times 5 over 8. We can cross cancel the 8's. Give me 1 and 1, so that's just 5. Now we have the equal sign. And we have the 8 times 2 and 1/4. So 8 over 1 times 2 and 1/4, I'm going to write as 9/4. Cross cancel the 8 and 4 gives me 1 and 2. 2 times 9 is 18. So we now have 6x plus 5 equals 18. So we go to solve it, and we have to subtract 5. 6x equals 13. Yes, and divide by 6. Now, just because we eliminated the fractions in the original problem, in the original equation, does not mean we won't get a fractional answer. 13 divided by 6, we're going to treat that as 13/6 and reduce it to 2 and 1/6. Any questions? So I'm going to have you guys try one. Give that one a shot. We'll talk about it in a minute. Okay, so as always, we could just go ahead and solve this by dividing out by dealing with the fractions. But we're going to go ahead and try to get rid of the fractions. What did you come up with for a common denominator for 3, 4, and 6? 12. So if we multiply this whole equation by 12, it'll eliminate the fractions. So we're going to do 12 times 2/3 x. I'll write that as 12 over 1 times 2/3 x. 12 and 3 cancel out, giving me 1 and 4. So 4 times 2 is 8x. We have the 12 times 3 and 1/4. So again, this is 12 over 1. 3 and 1/4 we're going to write as 13/4. And the 4 and the 12 will cancel out, giving me 3 and 1. So 3 times 3 is 39. Then we have the equal sign next. And we have 12 times 7 and 5/6. This is 12 over 1 times 7 and 5/6. 7 times 6 is 42, plus 5 is 47 over 6. 6 and 12 cancel out, giving me 1 and 2. So 2 times 47 is 94. So once we have removed the fractions, now we can just solve this. We subtract 39. 8x equals 55. And we divide by 8. So x equals 6 and 7/8. Yes? Pardon me? The 12? Up here? We're looking at 3, 4, and 6. So the smallest number that all those go into would be 12. Okay. Now the reason I'm showing you this method, it might be easier to just deal with the fractions, especially if you have the fraction calculator to combine them. But there are going to be some equations out there that have to use this method to solve them. So we might have something like 3 over 5 plus 7 over 10x equals 4 over 5x. And to solve this, the only way we can solve this is to multiply by that common denominator. So we have a 5, we have a 10x, and we have a 5x. For the numbers 5, 10, and 5, what's going to be my least common denominator? 10. Very good. And then for the variables, it's the highest power, which is just going to be x, so 10x. So that is my least common denominator for those three denominators. So this whole equation is going to get multiplied by 10x. So I'm going to do 10x times 3/5. So I'm going to do 10x over 1 times 3 over 5. The easiest way to do this is probably just to multiply it out and reduce. 10x times 3 is 30x over 5. That 30x divided by 5 is 6x.
So you multiply it like that when you have one variable, you still keep the x.
Yes. Now in this next one, you'll see 10x over 1 times 7 over 10x. Here you multiply that out. 10x times 7 is 70x. 1 times 10x is 10x. Well, 70 divided by 10 is 7, but the x's divide out because there's one on top and bottom. Here's because there's only an x in the numerator, the x stayed.
I can't put an x squared.
Okay, gotcha. Equals, now we've got the 4 over 5x times the 10x. So we got 10x over 1 times 4 over 5x. We multiply that out. 10x times 4 is 40x. 1 times 5x is 5x. 40 divided by 5 is 8, and the x's do divide out. Now this is one we can solve. What would we do next? Subtract 7. 6x equals 1. Divide by 6. So x equals 1/6. What do you think?
The exponent rules.
Yeah.
I always get them mixed up and
Sure.
when to cancel and when to subtract.
Okay. Go back to your rules of fractions like this. If you have, like 70x over 10x, you divide the numbers. 70 divided by 10 is 7. And then you can cancel out common factors. In fact, that might be an easier way to think of this. 70 is actually 2 times 5 times 7. And of course times x because it's x. 10 is 2 times 5 times x because there's an x there. Then you can cancel out common factors. You can cancel out a 2, a 5, and an x, and all you're left with is 7. So that's one way to think about it. That factoring like that is really a powerful tool. I mean, we touched on it just a couple of times, but if we had the time to slow down even more, we would use that factoring a lot because it is an extremely powerful tool. That factoring actually could help us find the common denominator. We could use factoring to find this 10x even if we wanted to. I mean, it slows down the process. It's easier if you can see it, but that factoring is an extremely powerful tool. A lot of our rules that we do with fractions actually can be done by factoring and canceling, or factoring and pulling in missing factors.
It just seems like it gets
It does. We're hitting some problems here that do take a long time. Unit 3 isn't too terrible because Unit 3 is on decimals. Then we're going to come back to Unit 4, which will be about our last 6 weeks. Unit 4 is going to be volumes and surface areas and stuff like that, and angles. And that's going to be longer processes as well.
skip that part. I seriously suck at angles and volume area.
Is it visualization? Is that something you struggle with, or?
I don't know what it is. I'll look at it and I'll be like, oh crap, what is this formula for volume? And it just unfolds. Area for corner and rectangle and stuff is different.
Different formulas?
Formulas, yeah. You know, just can't keep them straight.
This type of problem here usually is a good indicator of who's going to struggle with the areas and volumes. So if I look at this, what is the length of this side here? Must be 7. Because, think of it this way. Those two pieces are the same distance apart no matter where we measure that distance, right? Here it's 24 feet apart. So anywhere else that we measure, it has to be 24 feet. So if this is 17, this piece here has to be 7 feet to finish it off, which would be the same as this piece. That's one, like I said, that's one of those that people that struggle with that problem, they usually do have to work harder with the areas and volume, because it's the visualization part, seeing how the pieces fit together is the problem. So then let's keep going. How about this piece here? How would you find that length? What is that length? Is that? Perfect. The 40 and the 22, which give us 18. So it's the same type of thing there. So you've got here and here. Those are the same distance apart. It's 40 units apart here, so it has to be 40 units apart up here. So if this is 22, this piece here has to be 18. So if it's 18 on top, it has to be 18 on the bottom of that rectangle.
And when is this one come out?
This is going to come up a few weeks after spring break. About 2 weeks after spring break, we'll start doing this. So, I think you guys have had enough for today. There is a new quiz that is due tomorrow. That's Tuesday at 11:59 p.m. And there is a new homework due for Wednesday. Wednesday will be review for the test, and Thursday is our test. So Wednesday's a big day to make sure we got everything down ready for Thursday. If anybody has any needs for the test, private room, extended time, or whatever, start arranging that now so you make sure you got room set up. So if you contact the library for the room or whatever, come and pick up your test from me then Thursday morning before you want to take it. Other than that, anybody have any questions?
Need the answer key?
For the right price, anything is possible. Is it starting to get like snowy or something, cold out there or something? Is it getting slippery?
No, it's just raining.
I know it was raining this morning. I thought maybe it was getting cold, that's why nobody showed up.
No, because it says it's supposed to be warm and just rainy, and then
Okay.
later in the